Assalamualaikum students. In this lecture, we will learn how to fit multiple linear regression using the normal equation method. In this multiple linear regression model, we have two independent variables. X1 is an independent variable here, and x2 is an independent variable, and y is dependent variable. And this is the random error term, and this is called constant or y-intercept. Now, there are two methods to obtain the least square regression line or least square estimate of the parameter. First one is using the normal equation method. Second one is using the formula method. You already know how to use the formula method. Now we will use the normal equation method. It is very simple. Uh, First, we multiply the main model, which is this one, number one, by summation on both sides. So we will get summation y equal equals n beta naught plus beta 1 summation x1 I plus beta 2 summation x2 I. Then this is the first normal equation. Then we multiply this main model by summation x1, and we will get this second normal equation. Again, we will multiply this model by summation x2, and we will obtain this normal equation. Now you can see that we have three unknown constants in our model, and we have three normal equations. By using these three normal equations and solving these normal equations simultaneously, we will find the numerical estimates of the parameters. Now, using our last example, our science putting the values in the normal equations, we have these normal equations. It is very simple. Just you have to put your values in the equation. Now solving these normal equations simultaneously using substitution method, cross multiplication method, cancellation method, uh, or any other method, Kramer method, which is matrix method, or there is a algebra matrix approach. Using this matrix approach, you can have the estimates these putting these estimates in the main model. We have this. Now you can see that we have two equations, one obtained from the formula method and one obtained from the normal equation method. They are the same. They are the same. Now now the problem of interpretation of the model we obtained. Now, beta 1 is equal to 0.204, which means that 1 unit increase in variable x, because the constant is belong with variable x1, may give 0.204 increase in the estimated average value of the dependent variable. Similarly, uh, beta 2 is equal to 0.28, which means that 1 unit increase in variable x2 may give 0.28 increase in the estimated average value of the dependent variable. Similarly, beta naught is equal to 0.0064, which means that the regression line almost passes through origin. Now, we will obtain the R square, which is the coefficient of multiple determination. The formula for R square in derivation form is given here. Now, using the summations of deviation forms obtained from in the last lecture, not in this current lecture. We will have the value of r square 0.97, which means that the 97% of the variation in response variable is explained by the independent variable, and rest of the third 3% variation is due to error. Hope that you understand this interpretation. If you have any question about this interpretation, you can ask question about it. Now there is an assignment for you, uh, how to interpret the output. Now you can see that there are two independent variables and one dependent variable. Now these are the estimates. This is constant, and this is the first regression coefficient. This is second regression coefficient, and this is the standard errors. This is t-test values, and this is p values, and this is, you can see that standard error of regression, degrees of freedom, r square coefficient of multiple distribution, adjusted r square, which is negative, f, the value of f is this, and p value is this. This example is taken from the book Quote Sonias, from page number this, and this is in SPSS output. SPSS output. You can interpret the result and give me the your assignment written on a page, and upload it on the Google Classroom. Thank you very much.